Hello students, I am Muhammad Rizwan. Today we are going to see the graphical representation of the frequency distribution for grouped data. The line graph, bar graph, pictograph and pie chart are the graphical representations of the frequency of ungrouped data. Histogram, frequency polygon, frequency curve and cumulative frequency curves (ogives) are some of the graphical representations of the frequency distribution for grouped data. In this class, we are going to represent the grouped data frequency by histogram and frequency polygon only. You will learn the other type of representations in the higher classes. Learning outcomes. After the completion of this lesson, you will be able to know: to understand the concept of graphical representation of the frequency distribution for grouped data, to understand histogram and frequency polygons, to learn to draw histograms and frequency polygons. Keywords from this lesson are set, axis, graph, distribution, frequency, class interval. Histogram. A histogram is a graph of a continuous frequency distribution. Histogram contains a set of rectangles, the base of which is the length of the class interval and the frequency in each class interval is its height. That is, the class intervals are represented on the horizontal axis and the frequencies are represented on the vertical axis. The area of each rectangle is proportional to the frequency in the respective class interval, and the total area of the histogram is proportional to the total frequency. Because of the continuous frequency distribution, the rectangles are placed continuously side by side with no gap between adjacent rectangles. Steps to construct a histogram. Step 1. Represent the data in the continuous form if it is in discontinuous form by converting it using the adjustment factor. Step 2. Select the appropriate units along the x-axis and y-axis. Plot the lower limits of all class intervals on the x-axis. Plot the frequencies of the distribution on the y-axis. Construct the rectangles with class intervals as bases and corresponding frequencies as heights. Each class has lower and upper values. This gives us two equal vertical lines representing the frequency. The upper ends of the lines are joined together and this process will give us rectangles. Difference between a bar graph and a histogram. Bar graph used for ungrouped data. Used for grouped data. Gap between the bars. No gap between rectangles. Height of each bar is important and not its width. Height and width of each rectangle are equally important. Construction of a histogram for continuous frequency distribution. Example. Draw a histogram for the following table which represents the age groups of 100 people in a village. Solution. The given data is a continuous frequency distribution. The class intervals are drawn on the x-axis and their respective frequencies are on the y-axis. Classes are edges and their frequencies, that is number of people, are taken together to form a rectangle. The histogram is constructed as given below. Construction of histogram for discontinuous frequency distribution. Example: the following table gives the number of literate females in the age group of 10 to 45 years in a town. Draw a histogram to represent the above data. Solution: the given distribution is discontinuous. If we represent the given data as it is by a graph, we shall get a bar graph, as there will be gaps between the classes. So, convert this into a continuous distribution using the adjustment factor of 0.5. The first class interval can be written as 9.5 to 15.5. And the remaining class intervals are changed in the same way. There are no changes in frequencies. The new continuous frequency table is shown below. The histogram is constructed as given below. Frequency polygon. A frequency polygon is a line graph for the graphical representation of the frequency distribution. If we mark the midpoints on the top of the rectangles in a histogram and join them by straight lines, the figure so formed is called a frequency polygon. It is called a polygon as it consists of several lines on the sides of a polygon. A frequency polygon is useful in comparing two or more frequency distributions. A frequency polygon for a grouped frequency distribution can be constructed in two ways. 1. Using a histogram. 2. Without using a histogram. To construct a frequency polygon using a histogram. Draw a histogram for the given data. Join the consecutive midpoints of the upper sides of the adjacent rectangles of the histogram by the line segments. It is assumed that the class interval preceding the first rectangle and the class interval succeeding the last rectangle exist in the histogram, and the frequency of each extreme class interval is 0. These class intervals are known as imagined class intervals. To get a frequency polygon, join the midpoints of these imagined classes with the corresponding midpoints of the upper sides of the first and last rectangles of the histogram. Example: the following is the distribution of time spent in the library by students in a school. Draw a frequency polygon using the histogram. Solution: represent the time spent in the library along the x-axis and the number of students along the y-axis. Draw a histogram for the given data. Now, mark the midpoints of the upper sides of the consecutive rectangles. Also, mark the midpoints of two imagined class intervals 0 to 10 and 90 to 100 whose frequency is 0 on the x-axis. Now join all the midpoints with the help of a ruler. We get a frequency polygon imposed on the histogram. Note that the first and last edges of the frequency polygon meet at the midpoints of the left and right vertical edges of the first and last rectangles. Because imagined class intervals do not exist in the marks. To draw a frequency polygon without using a histogram. Find the midpoints of the class intervals and tabulate them. Mark the midpoints of the class intervals on the x-axis and frequencies on the y-axis. Plot the points corresponding to the frequencies at each midpoint. Join the points using a ruler to get the frequency polygon. Example: draw a frequency polygon for the following data without using the histogram. Solution: find the midpoint of the class intervals and tabulate them. The points are A 5, 0, B 15, 4, C 25, 6, D 35, 8, E 45, 12, F 55, 10, G 65, 14, H 75, 5, I 85, 7, J 95, 0. In the graph sheet, mark the midpoints along the x-axis and the frequency along the y-axis. We take the imagined classes as 0 to 10 at the beginning and 90 to 100 at the end, each with frequency 0. From the table, plot the points. We draw the line segment AB, BC, CD, DE, EF, FG, GH, HI and IJ to obtain the required frequency polygon A, B, C, D, E, F, G, H, I, J. Summary of the lesson. A histogram is a graph of a continuous frequency distribution. Histogram contains a set of rectangles, the base of which is the length of the class interval and the frequency in each class interval is its height. A frequency polygon is a line graph for the graphical representation of the frequency distribution. Thanks for watching.